Concentrating on perpendicular lines and transversals. So let's go ahead and jump right in. Given the diagram we have right here, why can I conclude that the measure of angle 2 is 90 degrees? So let's think about everything that we know. When I look at the diagram, the first thing that kind of pops out are these markers right here. And those markers are telling me that line A is parallel to line B. If I know my lines are parallel, I can look at all those special relationships that I have: alternate interior, alternate exterior, same side interior, same side exterior, and corresponding. So I have angle 2 right here. I look at this indicator. This indicator means that I have a right angle. And we know that right angles are equal to 90 degrees. So when I look here and I look here, these two angles have to be congruent because they are corresponding angles. So here in the diagram, line C is the transversal cutting through two parallel lines A and B. Therefore, angle 2 is congruent to the given right angle because they are corresponding angles of parallel lines. Now remember, if the lines weren't parallel, they would still be corresponding, they just wouldn't be congruent. So the alternate interior, all of those relationships exist whether the lines are parallel or not, but if they're parallel, we get that congruent relationship, we get that supplementary relationship. So let's look a little bit more into perpendicular. Here I'm told that line T is perpendicular to line M. So line T perpendicular. If it's perpendicular, we've got these right angles. But I see once again we've got parallel lines, which means if this is a right angle, this is a right angle. If that's a right angle, that's a right angle. You may be thinking, well, there's a lot more right angles here. Yes. If you have a perpendicular line like this, then all four of these are going to be right angles. I could either use my linear relationship, I can use vertical angle relationships, jumping from one parallel line to the other. I can use alternate interior, same side interior. Any way you look at it, if one angle is perpendicular, they all are going to be perpendicular. So this makes this really easy. This angle right here is 6x plus 24. If this is a right angle, 6x plus 24 has to equal 90 degrees. Remember, we're crossing that equal sign, so we have to do the opposite. That leaves us with 6x is equal to 66. We undo multiplication with division, so we find that x is going to be equal to 11. And believe it or not, this is our last one. In this one, we want to solve for x and for y. So again, we see that our lines are parallel. Because they're parallel, we can use all those relationships. So if this one is a right angle, I have a congruent corresponding angle. So if this is 90, this also has to be 90. Then we can use our linear pair, say that's 90. Linear pair, congruent, vertical angle. All four of these on each line, so 8 angles total, are all going to be 90 degrees. So the first angle here, 3x plus 18, has to be equal to 90. And a negative 4x plus 8y, this is also going to be a 90 degree angle. Now you may be getting a little nervous when you see x's and y in the equation, and you're right. Normally when I see an x and a y in equation, I'm going towards systems of equations. And we don't like systems of equations so much, but if I look back at the first equation, all I have is x's. So this is where I'm going to start. This is a good equation. Not too much work we have to do there. We move the 18 over. 3x is equal to 72. To undo multiplying by 3, we divide by 3. 72 divided by 3 gives us x is equal to 24. Now you could be thinking, but I still have the second equation, and yes, we do have to solve for x and y. We just solved for x. I can use this to plug into that other equation. So we have a negative 4 times x, which we found was 24, plus 8 times y equals 90. When I substitute in that value of x that I've already solved for, now I have a lot less work to do. I have one variable, makes it a lot easier. So negative 4 times a positive 24 gives us a negative 96 plus 8y equals 90. We want to move this negative 96 over, so the opposite of a negative is a positive. Because we're crossing that equal sign, we've got 8y equals 186. 186 divided by 8 gives us y equals 23.25. Remember, decimals are not bad. When you have clean decimals like this, write them as decimals. If they're crazy, weird decimals, then you leave them as a fraction. All right, so that's everything that we have for perpendicular lines and transversals. The takeaway is perpendicular creates these right angles. All right, all done.